Hi everyone, welcome back. Today we're solving concatenation of consecutive binary numbers. So in this problem, we'll be given an integer called n, and we want to return the decimal value of the binary strings formed by concatenating the binary representation of 1 to that number in order. And if it's too large, we will modulo by this number. So if we look at this example, when n is 1, 1 to 1 only has 1, so the decimal value will be 1, so we return 1. If it is 3, we will have this as 1, this as 2, this as 3. Add them together, it'll look like this, and this corresponds to 27. In this example for 12, if we add up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, this will be the complete string you get in binary representation, and the decimal value of that would be this, but it's too large, so we modulo by this number, and it would be this, so we return this as our result. So now that we have seen some examples, let's get to how we can solve this problem. So to solve this problem, there's one thing that we should know, and it's that if a number does an AND operation with the number -1, and if it's equal to 0, then the length of the binary representation will increase by 1. So for example, right here, if 4 does an AND operation with 3, we see that if this does AND with this, it will equal to 0. And we know that the length of 4 is increased by 1 compared to 3. And it's important to know that when we need to add a number to result. So for example, let's say we have 1, 2, and 3, and now we want to add 4 to it. We will need to shift left and fill in these spots. And we can note to shift left by 3 because originally we are shifting by 2, and since 4 and 3 is 0, we need to change the spot we shift to 3, so we can shift this to the left by 3 and then fill in the spot of 4. So now that we know that, we can use that to solve the problem right here. So what we'll do is we first initialize result and length to 0. So result would be what we return, and length would be the length that we shift the number by depending on where we are at in the problem. So we will iterate from 1 to n because these are the numbers that we are adding to result, and we want to check the number first. If the number and the number -1 is equal to 0, make sure we increase the length by 1, and then we will shift result to the left by the length amount. And finally, we will add the index that we are on to result using the OR operation, and then finally we can return result. So let's go through this example real quick. So first we're at index 1. 1 and 0 is 0. So we will need to increase the length by 1. And now we will take 0 shifted by length 1 or operation with 1. And that will make it equal to 1. So we will set result to 1. Now we come to index 2. 2 and 1 is equal to 0. So we need to increase length again. And now the result 1 shift to the left by 2. And we will do an OR operation with 2. So we can add that to result, and this will be 6 in decimal. So now the result is 6. Now at index 3, 3 and 2 is this in binary representation, which is not 0, so we don't need to increase the length, but we have 6 as result right now. Gotta shift it by 2, and we can add 3 right here. So now this will be what the binary representation looks like, and in decimal that would be equal to 27 because we have 16 plus 8 plus 2 and plus 1, and that would be 27. So we can return 27 as the result. So the time complexity would be O of n, where n is the size of the number because we have to iterate through that many numbers to add to result. And the space complexity would be O of 1 because the size of length and result will not depend on the size of the number. So now let's get to the coding part. So first we'll initialize mod to 10 to the 9th power plus 7 in case the numbers get too big. Now we'll initialize length to 0 and result to 0, and we will iterate for I in range 1 to n plus 1. If I and I minus 1 is equal to 0, increase length by 1. And now we can shift result to the left by length and do an OR operation with I, modulo by mod in case it's too big. And after all that, we can return result. Let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.